hello everyone, and thank you for joining me. And this talk is about unit testing. This talk is about a specific thing about unit testing, that is testing data fixtures or test data. And let me begin with a fun story. So I was having a chat with my colleague that these conferences are 4 days of conferences. We get to know a lot of frameworks, libraries, like a lot of information. What new that I'm trying to bring in, right? We talk about test containers. I think there was a nice presentation a little before in this room about test containers, about testing databases. So there are different aspects of unit testing. This talk primarily focuses on the data fixtures that we need for writing JUnits. So in this talk, what we are going to cover is 3 key pillars. One is randomness, repetition, and the last one is edge cases or corner cases. These are the 3 main things that we are going to cover. And throughout the next 15 to 20 minutes, we would be taking a look at what we are doing now, let's say, without making use of the libraries to generate the data. What are the benefits we can get out of the automation? And a few libraries that I have found myself interesting, that I have seen my colleagues doing nicely, and then we'll talk about some examples, use cases, compare, and those things. So 2 things to begin with. Introduction about myself. My name is Parichay. I'm Indian. I work with ING Bank in the Netherlands as an expert engineer. And the next important thing is for questions and feedbacks. The point where I started this talk is when I was talking to my colleague, working with my colleague, and I got to know about things. And that's how we spread the information. That's how we share our experience and knowledge, lessons learned. So therefore, your questions and feedbacks are very much appreciated. So to begin with, we'll talk about the ground or the base, that is example-based testing. And gradually from there, we'll go to automation. We'll go towards property-based testing and so on. And so example-based testing, and this concept is not new. It's probably you would call it something different, but essentially we are doing JUnits with an example to start with, and thereafter we try to test the function or the methods at target. But we start with an example. In 2006, this blog post was shared from Martin Fowler about object mother. Object mother is something that when you start with unit testing, you start with the basic structure, and you build up the complexity as the code and the functionality evolves. You build up on top of that. In ThoughtWorks, this was something coined, but it's in general. So you create some basic abstract data, and then on top of that, you create different derivations, let's say. And then applied with builders and factories. These are very trivial examples, but then you understand that's how we are managing complex data for our JUnits. And with annotations, with JUnit 5, we have better ways to manage. Very popular, quite used annotations like CSV or external methods, etc. This is good, right? But then we're still writing the data manually. And let's talk about some of the limitations now. The first one is pesticide paradox. So this is about when you apply the same pesticide again and again on the bug tends to get immune. The same thing happens with the data as well. When you do not change the data, but your code evolves over the period of time, you might be losing to find potential bugs. That's pesticide paradox. And this is something that I coined myself, but you would be very well aware Foobar is good for POCs, but not for production code. But we tend to use data like account 1, account 2, account 3, and I have seen this almost everywhere. We do this, but that creates noise. It works, but it's not nice. We could list down the limitations of static data, and maybe if we spend more, we get more issues when we do it manually. Huh? And one point I like is the last one, distractions. A lot of the time, I was creating an account POJO, account data for unit testing, and I was only looking for some combinations of account numbers. So all the other data that I was creating for account object was a distraction for me. So if we switch towards generation, randomness gives us the ability to do monkey testing. You could think of covering the edge cases. And fewer lines of code is always good for the person who is writing the code and also for the person who is doing the peer review. And now, at this point, I'm going to introduce 3 open source libraries. And the first one is DataFaker. In the previous the talk before that, it was mentioned. I'm going to do a quick introduction to DataFaker. And the reason I liked it is it's very well documented. It's a continuation from JAVAPRO, but then it's very well managed, well documented, well maintained, and very simple. The APIs is, as you can see, you create Faker, and then you have existing providers. And those providers are something which is, there are a lot of providers. You have account information, IBANs, you have finance, you have insurance, health, mostly all the domains. And as we speak, this slide was a month old maybe, but there are over 250 data providers. And the best part is you could create your own provider as well if you need. It's very well documented, so I'm not going to go to all the details. If you open the link, it says how you create your own extension, how do you extend the providers. And then either you use it locally or you push to the central source so that others can also use it. And I'm going through a little first, but if you have questions, you can post it. I was in a hackathon. I was doing a demo application where I had to create 100,000 accounts. And I was supposed to show that demo to management teams. So I couldn't use the foobar kind of test data. I had to use real names from a locale of Netherlands, IBANs, addresses. And these DataFaker helped me a lot because it created instantly 100,000 accounts. Locale specific, as I mentioned before, there are software where you need, let's say, specific Netherlands or Germany specific addresses to be tested. Huh? So that's good. But then, what happens if you are testing a large API, for example, a REST API, which has 50 input parameters? And for that reason, the second library that I'm going to introduce to you is Instancio, which is, again, very well maintained. It has good documentation. It supports, it scans through the entire object graph and by reflection, Java reflection, and then it fills up with random data. The best part is, as you see, it adheres to the JSR 380 bin validation logic, so it's not going to create false positives. The API, as you see, is very simple. And this is one example that tells you how it goes in the depth of the object and creates the structure. By default, it is 8, but then you can make it customizable. And one thing which I'm not going to include in this short talk, which is the possibility to do customization. All these libraries are very well, they're matured libraries. As you can see, the first one I'm doing, let's say, a generation, and then I'm extending the generation to be more specific for the need that I have, be it a collection or be it conditional, so that there is a lot of possibility. And there was a question initially when I was preparing this, I received, how do you make sure that flakiness is not slowing down your CI/CD, right? And so that is possible with a seed. So every time you receive these generation engines to, every time it creates random data, it has a seed. And when it fails, it tells you in the log for which seed it failed. Then you stop the world of randomness. You reproduce the error with a particular seed, with the seed annotation. And then you get to see what the issue is. So it's possible. Now, let's move on. So with the DataFaker and Instancio, we talked about randomness. And we still have to cover repetition and edge cases, corner cases. And for that, I'm going to introduce to you, as I said earlier, from an example-based testing to a property-based testing. But a quick show of hand, if anyone you used or heard of property-based testing in Java or otherwise? Anyone? A few hands. Thank you. Thank you. Super. So let's not spend too much time defining the property-based testing, but let's try to see what a property is, and then we go from there. A property is a rule or a claim that a function expects to be true. Okay? But as I said, let's not spend time on the definition itself. We'll see some examples. So a reverse function, if you apply the reverse function 2 times, you get back the original string. So then I can say a property of a reverse function is such that you apply 2 times, you get back the original. Or you can also say a reverse function property is all the elements are going to be staying the same, the length of the string staying the same, etc. Those are properties. For sorting as well, we can find properties such as after you sort once, unless you change the algorithm, it's going to be staying the same. But these are trivial examples. Let's take a level further to see how this can be applied to our enterprise applications at work, not the trivial ones. Then we'll find that we do a lot of idempotent functions. Let's say you update an address 2 times, and you expect that the second update would not fail. So that's a property. The next one is serialization, deserialization. We do a lot of times. And unless we make a change, we expect from a SAR/DAR that if you deserialize the same string, you get back the one that you serialized. Invariant is a nice example. Sanitization is a nice example. If you're sanitizing the data, then you expect certain properties to be invariant. For example, the length of the string would still remain the same. The regex can still remain the same. So there are a lot of good documentation over these on the internet, but in the interest of time, let me move on with the library. We talked about DataFaker, we talked about Instancio. Now we'd be talking about Jqwik. But if you want to understand Jqwik, please be aware that the starting of property-based testing was with quick check, which was for Haskell. Thereafter, hypothesis, by the way, is quite popular as well. Jqwik is one Java implementation, or one library for Java, but then there are other libraries for Java as well. It happens to be Jqwik that I choose now, and it's for Kotlin as well. If you're a Kotlin developer, it's going to be there for you as well. Again, It is well documented, but there are specific things that I want to highlight and specific features of Jqwik or property-based testing in general. The first one that I want to say is it helps you to cover the corner cases. Out of the box, by default, it gives you 1,000 repetition. You don't have to think about that. And it has a wonderful property called, a feature called shrinking. And we'll see an example of shrinking in a moment. And it, of course, gives you the entire object graph. But in essence, the purpose of property-based testing is that you or me as a developer, we should be worrying about the properties under test and not the data fixture itself. Therefore, the part of data generation goes to the library. You are abstracting it away, and you are concentrating more on the properties. You are busy finding the properties. A simple example, and the yellow highlight, if you see, I'm defining the scope or the boundaries for all positive integers, for upper characters, and then I'm testing, right? So what an output of this is, if you see, it gives you 1,000 combinations of integer and upper character string. It gives you 12 edge cases, and it gives you randomized data. So that means it gives you randomness, repetition, and corner cases. And I was interested to see that how random the data is, how does it cover the corner cases. Here is one example. So the uppercase characters that I used with a reporting generated annotation, if you see, some of the characters are empty or a single character, and some are very big. And then you also have the possibility to play around with, or based on the requirement, to add different ASCII characters, alphanumeric characters, and so on. Large integers. Possibility for customization. For this case, I have a specific integer that I want, which is based on my requirement. Let's say, for example, where I want the integer to be in between 0 and 100, and I want it to shrink towards 20. So the randomness would be concentrated on the value 20. So the documentation contains lots of such examples. Shrinking is the next thing that I want to talk about. This is, again, a trivial example. Let's say I have a reverse item function wherein I'm trying to reverse, but then the implementation, of course, has a bug in it. And we'll try to see how Jqwik helps us to get to that bug. I write test cases for this. For all non-empty list of integers, I am asserting that the property of a reverse would be first item would be same as last item after reversal. And this is an output where it tells me shrunk sample is 11 steps, 0, 0, 1, and the original sample is this much. So that tells you it tried those many repetitions, 1,000 repetitions, let's say, with different variety of array sizes, list sizes, but it then shrunk towards this one input that was enough to fail the test. That is 0, 0, 1, if you remember the bug that we had. So that is called shrinking, and it took 11 steps to shrink to that failure. So that's a property of, that's a feature of property-based testing, but then it's very nicely implemented in Jqwik. So it basically removes the noise from the test results. It takes you exactly where the problem is. Benefits, I would say, as you see, it covers the corner cases, gives you the ability to do a repetition out of the box. That's smart, I would say. And of course, all this gives you better coverage. But then it's difficult to think of properties, isn't it? And flaky test, I think we covered already with the seed. You can work on the flaky test. But we'll give a little bit of focus on the property itself. And this is ideally the best thing that I found is when you are asked to solve a maze, it's difficult. But when you have a solution, if you ask to see whether is it a correct solution, it's easy to prove. The same thing happens with a lot of patterns. Now, here are some of the patterns. So let's say you are transforming the data from one to another. There are certain properties which is invariant. The next one is if you transform the data from one state to another state, applying the reverse function would reverse it. Here in this example, it tells you a pattern where, regardless of whether you apply two operations in whichever order, it should lead you to the same result. The next one is the more you change, the more they stay the same. Regardless of whether you are changing a set in which order, it remains the same. So a smaller problem first. And the final one that I have is test oracle. So a lot of times, you cannot test, let's say you are using a library, which is a vendor library, you cannot test that. But what you can do is, you can create, it's called test oracle. You can create an alternate algorithm, alternate solution, and try to test that system and see if that simulates the behavior that you are expecting. And going towards the end, what I want to say my experience is, you would still find example-based test. We started with example-based test, right? So example-based test is still relevant. I have seen examples when I join a new team, new project, and I go to the test cases sometimes to find what the complex code is doing. So example-based tests are easy, they are readable, and if they are well maintained, that's quick to read and write. DataFaker is a wonderful example, especially for locale specific data. Instancio for large objects, it fills up the data. And Jqwik is particularly outshines when it comes to property, when it comes to all these three properties together, property, randomness, repetition, and corner cases. There is one caveat here that we should remember. Let's say you want 1,000 valid email IDs that you want Jqwik to generate. It's going to be slow. So there are situations where you do not want to put property-based testing with such big volume of generation in your CI/CD pipeline. You might want to profile them for a specific purpose. So that to remember. So that's all about my talk about generating test data. Thank you.